5.2, we're gonna go through this complementary angle theorem. We talked about this a little bit, but I didn't really have time to go over any problems or anything. So the idea is real simple. The sine and cosine are cofunctions. That's why we have that term co as a prefix. The tangent and cotangent are cofunctions. Secant and cosecant are cofunctions. You don't have to memorize which is which because it's built into the way we do the words. And then the other thing is these angles are complementary. What does it mean for an angle to be complementary? It just means they add up to 90 degrees. Okay, so the sine of 30 and the cosine of 60 are the same. The tangent of 40 and the cotangent of 50 are the same, so are the secant and cosecant. Okay, those are called cofunctions of complementary angles are always equal. I think we went through at the end of class last time and I showed you kind of why that works just with a right triangle. So these things right here we're just going to fill in our head. This is super easy to do. So the cofunction of the sine would be the cosine. What would the angle be? 50 degrees, right? Okay, 50 and 40 are 90, okay? The next one, what's the cofunction? The cotangent, what's the angle in your head? 89 degrees, right? Okay, because those angles have to add up to 90 degrees, okay? Next one, cosecant goes with secant. What's the angle? 8 degrees. Okay, everybody with me and what I'm talking about there? Okay, all right. And then the next one, well, it would be the sine. I might have to use the calculator on this. What I'd have to do is I'd have to do 90 minus 8.67 to get that answer, and then you could use your calculator on that if you want to. So let's see what that is. 90 minus 8.67 would be this. So we would end up getting on this one the sine of 81.33 degrees. Okay, so that's all there is to it. Everybody okay with what I just did? Okay, cofunctions, you want to know what a cofunction is and how they relate to complementary angles. Okay, so the way this would go is, this is more like a formula, so you would say tangent, and then you would say 90 minus x. So that's what you're always doing. To get a complement is you're always subtracting from 90. Then the next one, the secant, its cofunction is the cosecant, so same idea, that would be 90 minus theta. Okay, that's all there is to that. Okay, it should be real simple for everybody. Any questions? Okay, all right, so that's what we mean by cofunctions of complementary angles, and those show up from time to time. The next thing I'm going to look at on the next page, these are the cofunction identities, and when you learn trig, there's a lot of identities you got to remember, but you know, if you kind of blindly memorize stuff without understanding, then it's hard. But if you understand, then it's easy to remember. So really all that's happening on these problems is this. I've just got the sine and cosine. Those are cofunctions. And then the 90 minus theta, well, that 90 minus theta, that's how you find the complement. Okay, so basically on these things, you can build these identities very easily. The only difference with this is, of course, we know pi over 2 is 90 degrees. That's just in radian measure. So you don't have to memorize these. It's actually pretty easy to do. So here's how I build it. If you pick a trig function like a sine, okay, its cofunction is what? The cosine. How do you find the complement? You do 90 minus whatever that angle is. Okay, so that's how you make the identity. You don't have to memorize those, you build them. Does that make sense to everybody? Okay, all right. So it's all kind of built into the definition. So with these two, these are in radians. So if you're going to do these in radians, first of all, the cofunction of the sine is the cosine. And we need to just do, instead of 90 minus pi over 3, we do pi over 2 minus pi over 3 like that, okay? So we want to get common denominator and work that out. So common denominator 6, so I'm going to multiply this by 3 over 3, multiply this by 2 over 2, and then that would end up giving 3 pi over 6 minus 2 pi over 6, so that's pi over 6, okay? Pi over 3 is 60 degrees, pi over 6 is 30 degrees like that. So that's all there is to that. Okay. All right. The next one, you would do the cotangent, and then again you would do pi over 2 minus pi over 12. You don't need to change these degrees, just leave them in radians and then get a common denominator. So I multiply by 6 over 6, and that would be 6 pi over 12 minus pi over 12, so that looks like that would be 5 pi over 12 like that. Okay? All right, so does anybody have any questions about what I'm doing with the cofunctions? Okay, all right, just make sure your angles add up to 90 degrees, or in radians they add up to pi over 2. Okay, that's the way it always works. All right, any questions? Okay, so usually that's not a very hard thing for students to catch on to. Now what we do, the other thing we want to do is a lot of these identities. So in trig, you're going to learn a lot of fundamental identities. An identity is just an equation that's always true for every angle theta where the trig function is defined. So basically there's several ways we can derive these. We already know these because these are reciprocals anyway. But what I want to do is just show you this. I'm going to derive one of these things. So the cosecant is 1 over sine, secant's 1 over cosine, cotangent's 1 over tangent, since they're reciprocals. Well, let's write down just one derivation. All we've really learned so far is how to do the definitions in a right triangle. So the definition of a cosecant is it's the hypotenuse over the side opposite. Okay? So what we're going to do on this then is, let's do 1 over sine and see if it doesn't turn out to be hypotenuse over opposite. So what I'll do is I'll change the sign. The sign is, you remember the SOHCAHTOA we've talked about, the sign is the opposite over the hypotenuse. Okay, like that. Well, really all you're doing with this is 1 divided by opposite over hypotenuse. If you divide a fraction, remember you flip and do the reciprocal of the second. So that's 1 times hypotenuse over opposite. Therefore, it is hypotenuse over opposite. And that's what the cosecant is. So that's just kind of the logical argument on that. You just need to know those identities. And really all you're doing is you're doing reciprocals of each other. One thing I want to mention about the identities is their equations, so you can rearrange them. For example, if you have cotangent theta equals 1 over tangent theta, okay, well, you can cross multiply. It's a proportion. So if you cross multiply, you would get tangent theta times cotangent theta is equal to 1. So all these identities can be written in different forms, see, okay? So you can write the identity like that, or you could even write it like this. The tangent of theta is 1 over cotangent theta. Okay, so there's different, what you can take an identity and rearrange it and solve it for a variable and get that in different forms. So really when you see this identity, you want to know that those 3 are just different forms of the same thing. Okay? All right, so these are what we call the reciprocal identities just because you're finding the reciprocal of secant, cosecant, cotangent by 1 divided by that. Okay, that's how you do a reciprocal, by the way. Okay? All right, so you want to know those. Next page, we'll get a little bit into the quotient identity. Some of these things are easier to learn when we start talking about the unit circle today. So we have the tangent is sine over cosine, and we have the cotangent is cosine over sine. And the way I look at this is you only got to memorize this one. The tangent is sine over cosine. Well, what is the cotangent? The cotangent is the reciprocal of the tangent, so it would be the reciprocal, so it would be cosine over sine, right? Okay, so these things right here are just reciprocals of each other. And these are identities that you're going to use quite a bit, so you want to make sure that you memorize these fundamental identities. I'll do a derivation for you on this and just show you how this goes. So it goes kind of like this. If we do the, and I'm going to start this derivation this way. Let's just write down that you have sine theta over cosine theta. And then we're going to use the definitions, and I'll show you how you get a tangent out of this. Okay. Well, let's see. The sine is the opposite over the hypotenuse in a right triangle. the cosine is the adjacent over hypotenuse in a right triangle. Okay, so that's a division problem, and you can do this in your head if you want to. I mean, what happens is those cross out, so you're left with the opposite over the adjacent. Okay, which trig function is opposite over adjacent? Have you got that memorized yet? That's the tangent. So katoa, the toa part, okay? So that's the tangent. So that's kind of the train of thought on that from your right triangle definitions, that they're the same then, okay? So you want to know these two quotient identities, and you'll get these down because you use these all the time for different reasons. When you go to calculus, you will use identities when you're dealing with derivatives and integrals. So these are things that you're gonna see a lot. You see a lot in Calc 2 primarily. Okay, so let's see. Next thing would be the Pythagorean identities. And I'll go through and just show you where these come from. What I usually will tell a student to do is at least memorize sine squared plus cosine squared theta equals 1. The other two can be derived from that. I'm going to show you how to do that. And that's kind of helpful because when you start learning lots of identities, it's good to know where they come from so you can derive them if you forget those. So here's what we're going to do for a derivation. So we got, let's just write down sine squared theta plus cosine squared theta like that. Okay, now we're just going to use the definitions. Okay, so the sine is opposite over hypotenuse, and then we square that. That just means you're squaring that quantity. And then the cosine is adjacent over hypotenuse, then you're going to square that quantity like that. Okay, well, what you end up getting is you get the side opposite squared over the hypotenuse squared, plus the side adjacent over the hypotenuse squared, okay, like that. All right, so what you end up getting, you've already got a common denominator, so you have basically side opposite squared plus side adjacent squared over that. Okay, now what happens is you got to understand this. So if you have a right triangle, and let's say that this is your angle theta, this is, let's say that's your hypotenuse, that's the opposite, and that's the adjacent. So how do those three sides in a right triangle relate to each other? They relate by the Pythagorean theorem, right? So you would have that side squared plus that side squared equals h squared. So what that means then is this thing right there is equal to the hypotenuse squared. Okay, that's just Pythagorean theorem is what I'm doing there. So what I end up getting is hypotenuse squared over hypotenuse squared, so it's 1. Okay, that's where it comes from. Now, this stuff to me, once we learn the unit circle, I think it's easier to see where these things come from. But, you know, you can play with the definitions, and that's where they come. These things are pretty similar. You want to memorize these. These things, particularly this one right here with the tangent, shows up a lot in calculus. So you'll deal with those from time to time in a calculus class. Okay, so those are what we call the fundamental identities. So you want to make sure that you know these. I don't give the fundamental identities like on an exam or anything, but I will give you some other identities because we're going to start learning a bunch of them. But the fundamental things show up so much that you need to know them. Okay, all right. Okay, let me do this because this is fairly important. You don't have to write this down unless you think it's helpful to you. And what I'm going to do is show you that if you memorize sine squared plus cosine squared, you can easily derive the other two. So it's worth writing down or at least paying attention to because I am bad about forgetting the other two identities, but I just derive them in my head, and I have to do that a lot when I'm teaching. So here's what I do. If you take this identity, that's the one students always remember, sine squared plus cosine squared equals 1. If I was to take this equation and divide both sides by sine squared theta, let me show you what happens. Okay, first of all, that would be 1. Anything divided by itself is 1. This right here is the cotangent. So if you look at the identity above, notice the cotangent is cosine over sine. So that becomes cotangent squared theta, and then 1 over sine is just equal to the cosecant. So that becomes cosecant squared theta. So that's where that identity comes from, see? Okay, does that make sense? Just divide by sine squared theta, and that other identity will pop out of it. And if you do this way, if you divide by cosine squared theta, then the other one pops out. Okay, so sine over cosine, remember sine over cosine is tangent. So this part right here just becomes tangent squared theta. This part becomes 1, and then 1 over cosine is secant squared theta. That's where they come from. Okay, so I do that all the time, and if you're going to forget identities, you just are, so you're better off if you know how to derive as many of them as possible and where they come from. Okay, all right, that's just something that I do all the time, is I forget those two, and I just derive them. Okay, it's easy. Okay, everybody with me there? How I did that? Okay, if you don't like doing that, you can memorize it too. Okay, all right, so let's see, last page on here, we're going to use these identities, just kind of do some expressions. What we're doing on the next page is kind of an exercise to help you learn some of these identities. And then we'll utilize these a little bit later in the class as we continue to study this stuff. Okay, so what we're going to do is just work out these problems by looking at the fundamental identities. Okay, so with this one, you're given the sine is a fourth, we're going to find the cosine. Now there's more than one way to do this, but we're going to use identities to find this then. Okay, so what you got to do is find an identity that relates the sine and cosine. That's the one that relates the sine and cosine. That's the only one out of that list that relates those two. So start this way, just write down the identity sine squared theta plus cosine squared theta equals 1. Okay. Now what we're going to do is I've given you the sine as 1/4, so this will be 1/4 to the second plus cosine squared theta equals 1. That's an equation that you can solve because it's got one unknown. That unknown is cosine theta. Okay, so what we would get if you square a fourth, you can do that in your head. A fourth times a fourth is 1 over 16. Then we have cosine squared theta equals 1. What we're going to do is just isolate the cosine squared by itself on the left side. So you would end up getting cosine squared theta equals 1 minus 1 over 16. Okay, and I'm just getting a common denominator. And we've learned how to solve this kind of equation. We've done this a lot this semester. So common denominator would be 16 over 16 on that. So what I would get is cosine squared theta is equal to 16 over 16 minus 1 over 16. So that would be cosine squared theta equals 15 over 16. Okay, is everybody with me there? Does that look like something you've done? You just haven't done this with a cosine. Now what do I do to both sides to change the cosine squared to a cosine? You do the square root, right? Okay, so you do square root of both sides. Now, what we do for now, the thing is theta, right now theta is an acute angle. Their textbook does this in a weird order to me, so you're not going to have the plus or minus on this. So what you would have is just cosine theta equals, you'd have square root of 15, and then of course the square root of 16 is 4, so that would be the answer of the problem. So if you have a sine, you can find the cosine by using that identity. Okay, I've shown you a little bit different way to do that before, but you want to do this with identities to get comfortable with this. Okay, all right. Okay, so let's see, the next one, this one you can do in your head. Okay, you need to find an identity that relates the tangent and cotangent. Well, the identity is this right here, cotangent theta equals 1 over tangent. Okay, and you can do this in your head. You don't even have to do this identity. What you're really doing is it's 1 over the tangent theta. Okay, well the tangent theta is 2, so that means the answer to the problem is 1/2. Okay, you can do that in your head anyway. The cotangent is the reciprocal of 2 over 1, so it's 1 over 2. Okay, so that's real simple to do. Okay, how about the next one? What would be an identity that you would use if I give you the sine and cosine? How do you find the tangent? What's the helpful identity? Sine over cosine, right, good. Okay, so what we do on this is the tangent theta is sine theta over cosine theta. Okay, I gave you the sine is 3/5. I gave you the cosine's 4/5. The 5's cancel out. Okay, you're just really doing a division problem, so you can do this in your head. So that divides out. So that means the answer of the problem would be 3 over 4. Okay, like that. Okay, so that's how you find a tangent if you know the sine and cosine. All right. Let's see. How about this one? A tangent and a secant. Which identity relates a tangent to a secant? I only see one. Which one is that? It's this one at the bottom, right? Okay, that's what we call a Pythagorean identity. So that's going to be the one we use. So you just start by writing that down. We have tangent squared theta plus 1 equals secant squared theta. I think that alpha was intended to be a theta. The variables need to match up. Okay, so what I do is I just replace the tangent with 1/3. So if I have tangent squared, that means you're going to square the 1/3. Then we have plus 1 equals secant squared theta, like that. Okay, then you got an equation you can solve. So a third times a third, you can do in your head, that's a 1/9. And you can get a common denominator, and you end up just doing the square root of both sides, kind of like what I did on problem A on this. So this would be 10 over 10. Okay, so that would give 1/9 plus 10 over 10 equals secant squared. You can skip some of these steps too if you want to. So I would just get secant squared theta equals 11 over, what in the world did I just do? The common denominator is not, I should have done 9 over 9, right? Okay, I don't know why I'm doing that. Okay, so it should go like this. That's strange. Losing my mind. Okay, so that is 9 over 9. I think I'm thinking ahead. I think there was a 10 that I knew was going to pop up, and I do that sometimes. Okay, so anyway, you would just get 10 over 9 equals secant squared, and then you would do square root of both sides. So the answer would be secant theta, and then you just write that as square root of 10 over 3 with the square root of 9 being 3, like that. Okay, and that's it. Okay. All right, so what you're doing is just pick the identity that you need to use, and then you solve an equation. All this is all about solving an equation and using the identity. Okay. All right, now let's see this next thing. Let me move this thing down here so I can kind of display this while I'm doing these. These also have some cofunction identities built into them. Some of these things you can do just like in your head, okay? Do you know what the answer to problem A is? That's 1, exactly, okay? So that's the identity. Sine squared plus cosine squared equals 1. Now those angles have to be the same. If they weren't the same, then it wouldn't be 1, okay? Now this one you can do in more than one way. Do you know what the answer to B is in your head? Here's the way I look at it. The cosine and secant are reciprocals. What happens anytime you multiply a number by its reciprocal? What do you always get? Don't you always get 1? So the answer is 1. You can think of it that way. Or you could do this. Okay, another way to do this is, okay, the secant is 1 over cosine. So you could just say, okay, leave the cosine alone, change the secant to 1 over cosine. Well, those things divide out, so you're going to get 1, okay? But if you see a trig function times its reciprocal, it's got to be 1, okay? All right? And this one, the identity that this one belongs to is tangent squared theta plus 1 equals secant squared theta. There's more than one way to do this problem now. So what I'm going to do is take this identity, which is tangent squared theta plus 1 equals secant squared theta, and I'm going to rearrange it so it looks like the problem I gave you. So actually, if I just move the tangent over there, then you get 1 equals secant squared theta minus tangent squared theta. Therefore, what's the answer of this problem? It's 1, okay? See, I'm just rearranging things. These identities are given in these forms. Remember, you can rearrange them because they are equations, okay? So that's the idea, okay? All right, any questions so far? Okay, and as you're doing these kind of problems and stuff, look at your identities, but try to get these things memorized. Now, the thing on this one I want you to notice is the angles are different. So we know that cosine over sine is cotangent, but the answer to this problem is not a cotangent, okay? Do you know what we could do? Let me ask the question this way. What's the relationship between 88 and 2? This is the first thing I talked about today. They're complementary angles, right? Okay. So that means that you can use that complementary angle theorem. Now, it's up to you how you do this. What I'm going to do is I'm going to leave the sine of 88 alone. Well, what could I change the cosine to? The sine of 88, right? It's the same, okay? Remember, the cofunction of the cosine is the sine, and if you do 90 minus 2, you get 88. So what's the answer to this problem? It's 1. The answer keeps turning out to be 1, all right? Okay, just coincidentally, but that does happen quite a bit then, okay? So if those angles are different, see if they're complements, and then that's going to have something to do with the complementary angle theorem, I think. Same thing with this. 40 and 50 are complements of each other, okay? So the way to do this problem, you can do it either way. I'm just going to change the tangent of 40 to the cotangent of 90 minus 40. You don't have to do that step because you can do that in your head. But what you'll end up doing is the tangent, we're just going to change that to cotangent of 50. Bring down the cotangent 50, so what's the answer? This time is 0. Okay, that's it. So learn to look for complementary angles, and if they have something to do with complementary angles, it probably has to do with it. See, notice this one, you have 85 and 5, okay? Now, let me ask this. On this one, you have sine over cosine. Now, they're the same angle, so what is the sine over cosine? That's tangent, good. So that would be tangent of 5 degrees minus cotangent of 85 degrees. Now the angles are different, so what do I need to do? What could I do with the tangent of 5? I could change it to the cotangent of the complement, right? So you need to understand that the tangent of 5 is the same as the cotangent of 90 minus 5. That's that complementary angle theorem that we talked about at the beginning of class. Okay, so what's the answer? 0. Okay, so the purpose of those problems is to get you to spot the correct identity and practice the arithmetic a little bit, and it's a good way to begin to learn your identities, okay, because we'll use these in equations and graphing and proofs that we're going to do and stuff like that, okay? All right, any questions about anything? Okay, to me in this section, the hardest part of this section is the problems I just did. I mean, that's the stuff that's the hardest.